Rotational molding places a lot of the responsibility for good manufacturing practices on the individual operator. The manufacturing practices of the operator have a direct effect on whether parts coming from a mold are quality or rejects. The basic process of rotational molding is relatively simple. First, the operator loads the correct amount of material into the mold. Then, slow rotation distributes the plastic around the mold. As heat is added, the plastic begins to lie down on the mold's surface. Finally, water and air help cool the part, hardening the plastic and preparing it for removal from the mold. When the mold has been cooled properly, the part is removed. If operators have followed good manufacturing practices, the part comes out easily, without damage. One of the most critical practices operators must follow is proper venting. Problems with venting is one of the major causes of rejects. Venting is important for several reasons. As the mold heats up, the air inside expands and creates pressure. Without a path of escape, the air could cause outward blowholes at the parting lines. The pressure can also cause damage to the mold itself. As the mold cools, the air inside contracts, creating a vacuum. If there is no means to relieve this vacuum, the part could cave in, or inward blowholes could form at the parting lines. The key for operators, then, is to properly vent their molds. Vent sizes vary according to mold volume, part wall thickness, heating rate, and peak internal temperature. As molds increase in size, the size of the vents increase to allow the larger volume of air inside to first escape during heating, and then to be drawn back in during cooling. The thickness of the part to be made can also have an effect on vent size. The thicker the part, the longer the cycle time will be. This lengthens the time over which the internal temperature rise occurs, thus reducing the rate at which air expands or contracts through the vent tube. Thinner parts will require larger vents than thicker parts. For a given mold, a rise or a drop in the pressure inside the molded part will be affected by the diameter, length, and material of the vent, as well as the rate at which the part is heated. This pressure will determine whether or not blowholes occur. An optimum vent will allow air to move freely enough to ensure that the pressure inside the part does not go beyond the critical point at which air can be forced through the parting line. Generally, there should be as much venting as possible. A 1 cubic yard mold will typically have approximately a 1-inch diameter vent. Larger molds should increase by a 1/2 inch in diameter for every cubic yard of volume. Smaller molds can use one or more smaller vents. Vents as small as 1/4 inch in diameter are commonly used in molds less than 1 cubic yard, 1 cubic meter, in volume. These guidelines are based upon practical experience. More detailed estimations of vent sizes for given mold sizes and part thicknesses have been calculated in this table. The figures in the chart are general guidelines. They do not take into account variables like pipe losses due to vent length, vent material, part thickness, part material, peak internal temperature, cycle times, and human variables. Remember, wherever possible, erring on the side of too much venting is better than having too little. There are 3 types of vents. Permanent vents are fixed in the mold and are usually made of stainless or mild steel. They will usually be in the line of draw of the mold. Removable vents are located using a boss through the mold and are held in place with a screw, wire, or clamp. They are usually made of Teflon, metal, silicon rubber, or phenolic. Actuated vents, which are still under development. These can be gravity vents, which open and close as the mold rotates, or pressure-activated vents, which open and close via a pressure signal through the arm of the machine. Vent location is also important. Vents should be placed in an easily accessible area for operators to reach, away from the wall of the part or areas where powder will build up over the top of the vent, and to a depth that allows the vent to reach the center of the maximum volume of the part. Good locations include areas of the part that will be removed and discarded, areas that create a useful hole, like the fill cap for a tank, along the parting line, or in the line of draw of the part. In order to properly maintain vents, use glass wool, steel wool, or cotton to prevent powder from clogging the end of the vent. Pack the filler lightly to allow air to pass through. When molding cross-link material, do not use steel wool, as it can ignite in the presence of volatiles. Make sure that the filler material is secure and will not fall into the mold. Clean the end of the vent and replace the filler material on every pass. For removable vents, check that the vent itself is secure in its holder. Teflon vents shrink after repeated heating and must be replaced periodically. An ideal vent would be Teflon or Teflon coated, tapered for easy part removal, and easily secured using quarter-turn locking. The vent should extend to the center of the largest free volume of the part. Close during molding of free powder. Open when the powder has adhered, and close when water is applied. Some applications require special venting considerations. Foaming applications will require more venting to allow expanding gases to escape uniformly. Crosslink materials need larger vents to allow peroxide gases to escape. Pressure systems, internal heating, or cooling mechanisms may use two vents or a concentric vent within a vent to raise pressure in the part and reduce warpage or bubble content. To install a vent, put the tubing in the hole provided in the mold. Adapt the size of your vent to the size and type of the part. Place filler material in the tube to stop material from escaping the mold and spilling into the oven. Pack filler material loosely to allow free airflow. If you have questions, your supervisor will instruct you on the proper technique. Check those vent tubes every cycle and clean or change them when necessary. Having replacement vents and cleaning equipment standing by will help your operation move along more smoothly. By understanding how much venting is needed, the type and placement of vents, and the proper maintenance of vents, operators will be able to produce quality parts. And that means higher production numbers and less waste of time and resources.